Find the power series representation for the following function. Include the interval of convergence. So our function is natural log of 2 plus x. We know that when we have something like 1 over 1 minus some function, let's say box, when we have this fraction, then we can always write this as the geometric series, that box to the n from 0 through infinity, and the radius of convergence is, or the interval is rather, found by the absolute value of that equals 1. Okay, so all that means as soon as we have a form something like 1 over 1 minus something, then we can write a power series in this way. But our question, this is not a fraction, okay? And we know that when we have a power series, we can integrate, okay? And we can also differentiate. Let's look at this function. Integration is not easy. How about derivative of this function? I'm just trying to get some idea. Derivative of this function is, in fact, ln of something is 1 over that times derivative of inside function from the chain rule, which is 1. Okay, we don't have to write that. Times 1 is not needed. Well, this is 1 over 2 plus x is kind of in this way. Okay, we can easily convert 1 over 2 plus x in terms of 1 over 1 minus something. Okay, so then we find the power series for this one. And to get back to this one, we need to do anti-differentiation, all right? Because it's a derivative, right? So we do anti-derivative. Because we were asked to find the power series for ln of 2 plus x. So let's find the power series for 1 over 2 plus x. So here 1 over 2 plus x is same as 1 over, we need 1, but there is a 2. So let's factor 2. There is no 2 there, but we can always manage 1 plus, okay, we can write x over 2. If we distribute 2 inside, then we can find 2 plus x. 2x, 2 times 1, 2, plus 2 times x over 2, 2 to cancel x. So this fraction is same as this one. Now this 2 we can put outside, in front, I meant 1 over 2 times 1 over 1 plus x over 2, like we can write 1 minus negative x over 2. Now this is pretty much like this one, okay, 1 over 1 minus something, the box here is negative x over 2, and we can write power series for this one 1/2 times, okay, this part is simply from here and from 0 through infinity of this negative x over 2 raised to n. And for the interval of convergence, this power series converges when absolute value of this is less than 1. Okay, this is a geometric series, and this happens to be the radius of convergence. Okay, let's simplify this. So this is 1/2 outside. Now inside is n from 0 through infinity of that negative x over 2 to the n. This negative is negative 1. We can just write down negative 1. And x to the n on the top. We can distribute that power over 2 to the n. And here absolute value of negative will be always positive. So that is same as x less than 2. Okay, you can multiply both sides by 2. So we have the power series. Maybe 2 we can combine inside, 2 raised to 1 outside and 2 raised to n. When we multiply, we add the exponent. So this is same as 1/2. No, okay, we want to take 1/2 inside. n from 0 through infinity of negative 1 to the n, x to the n over 2 and 2n is 2n plus 1, and this is the case. So this is the power series for 1 over 2 plus x. Okay, we've seen this in earlier examples as well. But our question, the function is ln of 2 plus x, and this is the derivative of ln of 2 plus x. So we want to integrate both sides. Okay, integrate both sides with respect to the variable x. So 1 over 2 plus x is equal to, so we are integrating n from 0 through infinity of negative 1 to the n x to the n over 2 raised to n plus 1 dx, and our interval of convergence still remains the same. And when we integrate, we get back ln of 2 plus x plus some constant, and we also get another constant from other side, and that constant and the constant from other side can be combined. So we can just write one constant, okay, collectively. You don't have to write on both sides. You can write, but those constants will be different, and we can combine, get just one constant. And this, since this converges here, this integration can be pulled inside. So we have n from 0 through infinity of negative 1 to the n. Okay, here is x raised to n. Antiderivative of x raised to n is x n plus 1 divided by n plus 1. And we already have 2 raised to n plus 1 on the bottom. 2 raised to n plus 1 and plus c. And this is in fact negative 2 to 2. Well, we are almost done. We are supposed to find the power series for ln of 2 plus x. Here is a plus c. And this power series is valid inside negative 2 to 2. For any number, for any x inside here. To find the value of c, how about, let's take x equals 0. That's the easiest. And that way we can find the value of c. So we have ln of 2 plus 0, just 2, equals 0 raised to power is 0, so the whole thing is 0, okay? Because we are taking x equals 0, that leaves c, okay? Then c is simply ln 2. So we go back, and this c is in fact ln of 2, okay? Thus, we have the answer. Ln of 2 plus x is sum n from 0 through infinity of negative 1 to the n x raised to n plus 1 over n plus 1 times 2 raised to n plus 1 plus c. That is now ln of 2, which is a decimal number. Okay, and this is our answer. But if you look at closely here, we got n plus 1 here, n plus 1, n plus 1, and n is just an index. So we can simplify if we like. Not needed, but so many n's, n plus 1 in 3 places. So what we can do is we can simply subtract 1 throughout in here, subtract 1 here too. Then we can start this index plus 1. We subtract all over 1. It simplifies, not needed. That we need to start from n equals 1. We still have the same series, by the way. Or this one looks a final answer. So this one is now n from 1 through infinity of negative 1 n minus 1 x raised to n. This is just n 2 raised to n plus ln 2. Generally we can write this at the beginning, this outside, and the interval of convergence negative 2 to 2 final. Okay, you can leave there.